Hi, eighth grade. We are continuing on with our chemistry unit. Today, what we're going to work on is the lecture part because this stuff can be a little confusing, but we're going to go step by step. We're going to look a little bit at the periodic table. Let's put this up. All right. And again, this first part shouldn't be anything new. Okay. Remember that atoms are the simplest, they are the smallest unit of matter. You can break anything that is matter down into these atoms. Okay. Different atoms are comprise different elements. Okay. And we already knew that. What you might not have really thought of. So, how do you find the mass of an atom or mass of an element? You cannot just take it and put it on a scale like on one of those triple beam balances that we use. You cannot just put it on the scale. So what scientists had to do, and this was in the 1800s. So think about no computers, no nothing like that. They would find the mass of a very large number of atoms, and then they can deduce the single mass of an atom. Okay. Remember though, not all atoms have the same atomic mass number. Okay, we talked about isotopes last time. So it's something to keep in mind. All right, atomic mass. So we've already talked about the atomic mass, remember, is the number of protons and neutrons. Okay, so even though you're given one single number of the atomic mass, so for the example, the atomic mass is 12, okay, you can deduce it's the number of protons plus neutrons. So if it's 12, it's 6 and 6, okay? Atomic weight, okay, atomic weight is something a little bit different. It's the weight of all of the isotopes that's going to be on the bottom. And again, we're going to talk about that a little bit more. This is the number of protons. Okay, remember that's the atomic number. So even though it's not labeled or anything, you can still see how many protons are there? 6. Okay. Dmitri Mendeleev, we don't talk, we don't really delve into, their personal lives and a lot of people who have been important in the history of science. But this guy is extremely important, and you will definitely be hearing his name again. Dmitri Mendeleev. Dmitri Mendeleev, as I said before, early 1800s. Okay, and he proposed that you can organize all of these elements based on their properties. Okay. Now, granted, we know that there are 118 elements today that we know of. Back then, maybe they knew 50. Okay, so he had these set of element cards, and he spent hours and hours and hours rearranging them based on what we already knew about them. For example, mass, density, stuff like that. Okay, so he had this chart, he had this table, okay, and it showed these repeating patterns. He did leave empty space, okay, because he saw with these patterns there was kind of missing puzzle pieces. Okay, there was missing pieces. Oh, there should be an element there. We haven't discovered it yet. Fast forward to 2020, we got a pretty in-depth periodic table. All right, so what does it look like? How is it organized today, at least? Just as an FYI, so everything about the periodic table, to the numbers, to the letters, to the colors, to what the symbols look like, everything is going to tell you something about an atom, okay, or an element. So for example, here, now I use the vernacular that your book uses. These color schemes are not universal, but like I said, this is the one that you're going to be using in your book, okay? So the color of the symbol, remember, the chemical symbol is the kind of like the nickname, okay? So white is going to be a gas. So for example, hydrogen, we know it's a gas at room temperature. Blue is going to be liquid. There's not going to be that many of them. And black is going to be solid. It's mostly going to be black and white, okay? Remember here, the atomic number, that's the number of protons. Okay? Symbol, the name, atomic mass, that's what we just talked about. Okay? Groups versus periods. So, periods. Let's look at this guy. Okay, this is technically period 3. Okay, so it goes 1, 2, 3. Periods are horizontal. Okay, periods are horizontal. Remember, if you're looking out onto the horizon, it's like a flat, okay, back and forth. So periods are horizontal, okay. Groups are up and down. They are vertical. Sometimes they're called a family, okay. These groups, oh, everything's kind of in the way. Let me stop moving. Yep, thought it would fade. Oh, yeah, there we go. Okay, so groups, they're up and down, okay. Those are going to share similar properties, okay. So for example, the group that's shown is group 17. Those are called the halogens. The halogens are the ones that make salts, okay. So you can see Cl, that's chlorine. So sodium chloride, that's a salt. Sodium fluoride, that's a salt. Sodium iodide, that would be a salt, and so on. So these guys all have pretty much similar properties. Okay, that's why they are all in that group. Okay, periods, they are all different, but they are predictably different. Okay, so as you go along, predictable changes can happen. Okay, so these guys are not super related. These guys are. So what are those changes that we were just talking about? Okay, again, this is from your book. This is directly from your book. Atomic size, so how big is the atom? It's going to decrease as you go down. You can see that here if you look at period 2. Okay, so this would be 1, 2. You start with lithium. He's a decent size. Go all the way down. Look at fluorine and neon. Pretty small, right? They're a lot smaller than lithium. Okay, the atomic size is going to increase as you go down. Okay, so lithium all the way down to cesium, pretty big. Okay, so you can see that pattern as you go to the right, it's going to get a little smaller. As you go down, it's going to get a little bigger. Densities does not follow that easy of a pattern. Okay, what happens is the densities are going to increase top to bottom. Okay, so up here, these guys, the top, not very dense, the bottom, pretty dense. Okay, and remember, just let me stop real quick. Density, we talked about it a lot with liquids. Not necessarily always the case, okay? For example, my go-to example of when you think of density, remember that is how much stuff is in a given space, okay? So think of our classroom. If I were to somehow get 200 people in there, it'd be pretty densely packed, right? It'd be very, very uncomfortable, okay? If I were to take them out and put 2 people in there, not very dense, right? Not a lot of people in the same exact space, okay? So how packed in are they? Increases top to bottom, I already said. Left and right sides are the least dense, okay? So our left side and our right side are not going to be very dense. The middle are going to be pretty dense, okay? So you can deduce that the densest elements on the periodic table are going to be these ones right on the bottom. So, as I've said before, you're going to have to be using the periodic table of elements to answer some questions, okay? It doesn't come right out and tell you, but if you know these patterns, if you know what the numbers mean, you know what the colors mean, you can pretty much figure it out, okay? So if I were to ask, what are 3 of the densest elements, okay? You could say tin, you could say lead, you could say bismuth, you could say antimony, anything down and in the middle, okay? If you were to say hydrogen, nope, hydrogen is not dense at all, okay? Its atomic size is tiny and its density is tiny, okay? But you know, even though it doesn't say anything on here about density, you would know that it would be there, okay? We are going to move on, but we will wait until the next video. So if you have any questions, please let me know before we move on, because as I said before, everything is kind of building on each other. So you need to know how to use this periodic table so you can answer the questions.